Good morning, everyone, and good evening to all the participants who are joining from India. First of all, let me apologize for the inconvenience which might be caused because of rescheduling of the sessions in our last week. I couldn't take the class last week because of some personal commitments. Sorry about that. But we are back today and we will continue with our session. Today will be our last class into Hadoop. Hadoop itself is a very vast thing. It is not possible to cover everything, but still, I've given you a glimpse of most things which you will be dealing in your day-to-day Hadoop role. Right? It may be as a system admin or it may be as a DBA. So I have given you an exposure to what might be your typical responsibilities in a Hadoop role. So today we will be continuing with our last class, and we will continue from our session which we left on was Hive. So we are meeting about after 2 weeks. So let me just help you recall what things we have covered till now. So in our module 7, we mainly talked about Hive. We looked at how you will set up Hive in an standalone mode, or we called it in an embedded mode where we can run only one JVM. Then we looked into how you can set up Hive by keeping the metadata into MySQL, right, into an RDBMS. We looked into Pig, right? So I showed you a few examples of Pig, how you can run Pig to do any kind of queries as we do in MySQL. Then we talked about Pig can run in local mode and it can also run in MapReduce mode, where in local mode it looks for files on non-HDFS space and also writes the output to a non-HDFS space. But in the case of a MapReduce mode, it looks for a Hadoop cluster, which is its default mode. So Pig by default looks for a Hadoop cluster. It looks for Hadoop underscore home variable, and from there it will come to know where are the config files, and from config files it will know where my name node is or where my particular job tracker or a resource manager is, depending upon which version of Hadoop we are using. Then we looked at Scoop, where we imported some data from MySQL. We had some data, a table. Then I showed you how you can use Scoop to import data. You can import the entire DB or a table, or you can selectively import data from an RDBMS into Hadoop. So when I said into Hadoop, there also we looked at use cases like importing data directly into HDFS, importing into Hive, and importing into HBase. Then we talked about Flume. So we configured a Flume source and a target in which we consume data from our Apache log. So whenever you write anything into Apache log, so that was uploaded into Hadoop. So Flume was doing that for us, right? Flume is ingesting data for us. Flume is a tool by Twitter. So you can use it to ingest tweets from your Twitter. So in our today's class, we will be building up on our previous session. So today we will be talking about HBase. What is HBase? How to set up an HBase cluster. Then we will look into Hive integration with HBase. Why we need Hive with HBase is because it makes things easier for us to query. For example, I cannot run select queries. I cannot run the joins which we are used to running over a period of time. Let's say anybody who is from a SQL background, he will be very comfortable running a select star from a table where this particular condition meets, which does not hold true in the case of HBase. There is no select, join or anything in HBase. So we will see how we insert data and how we select data. So select in HBase turns into scan, and there are also few commands for HBase management. Then we will look into MapReduce phases. Up till now we have only talked about map and a reduce phase. But there are also other phases like map phase and a reduce phase. We will look into detail of those as well, like shuffle, combiner phase, sort phase, partitioner phase, right? So we'll try to understand what are those. Then we will look into some performance tuning aspects. Very vast topic altogether, performance tuning. Just imagine you have to tune a standalone Linux box. A lot of things goes into it. Here we are just talking about a subset of things which you need to take care of. So obviously when we are tuning Hadoop, so obviously your operating system, it might be your CentOS, Red Hat, must be tuned for it to run or the optimal HBase on it or optimal Hadoop on it. Then we will also look at what is snapshots, how you will enable snapshots, and what is the use of snapshots. Also, we will talk about NFS. For example, currently what we are doing is, let's say if I go to any of my box, right? Let's say I go to my client, and if I log into my client, right? So let's say I'm sitting on my client, I do Hadoop fs-ls. So it will list me the data which is on HDFS. If I need to copy something, I have to say put something, put file name into HDFS. But can I use file copy commands? These are file commands, native cp command, mkdir command, delete command, right? The native operating system commands on Hadoop. So how we will use that? We will mount the HDFS as an NFS into our system, and then we will run the same commands there. So we will see that also. And then we'll talk about Hadoop upgrade. So let's start with HBase. So what is HBase? So HBase is an open source non-relational distributed database. It is a contribution by Google. So it is based on a database which was published by Google called Bigtable, written in Java. Then it was contributed to Apache under the AFL license. Right now it is one of the topmost projects under Apache. So it provides you big table like capabilities. So what are those? We'll see into that. So HBase is a non-relational distributed database. You will use HBase when you need random real-time read-write access. For example, your Hadoop is not designed for real-time because there is always some overhead involved in invoking a job, running MapReduce on it, and then writing an output. It is not a real-time system. It is a batch processing system. So how you can leverage it if you have to do some queries which are very sensitive to latency. So HBase is one which helps you with that. You can do read write and also the random access of data. You have versioned data sets. So what does it mean? Let's say I have a table in which there's an entry say user Aman, his salary is 10,000. Tomorrow I update that saying Aman user is now having salary 15,000 with today's date. I have the capability to go back to the previous version. Means it automatically kind of keeps a versioned copy of each data. By default, it keeps 3 versions. So all those who are from OpenVMS background, so they can relate it to the versioning we used to have in VMS systems. Any file we create will create 3 versions for it. Similarly, HBase also keeps 3 versions for it. So we can go back in time up to 3 versions. It is changed. We can change the configuration of that. It is a configurable parameter. I can keep 5, 10, 20 copies. But obviously your data size will increase then. It is easy to scale, right? And easy to partition. So this is what it means, linear and modular scalability. So all those who are from a database background, they understand how tedious task it is to manage a large database. Because when your data grows beyond certain point, You have to take care of sharding it. Sharding means partitioning it across different boxes. How you will partition it? Vertically. And how you will scale it? Will I add one server, two server? And whenever you are writing a query, I have to write the query which will be shard aware, means partition aware. But in the case of HBase, all these things are gone. All these complexities are gone. The framework takes care for everything for you. HBase framework, it distributes the data for you across multiple nodes, and your data can grow as big as your cluster is, right? Your database size. So I will come into detail after of this in a minute. So this is what I was saying: automatic sharding of tables. It is an automatic failover between region servers. What are region servers? We will come to that. They are similar to how data nodes. Like you have multiple data nodes, you have 3 copies of data. If one data node goes down, you still have a copy. Similar to that, region servers will also be kind of, they are slaves of HBase master, right? So HBase also works on the same architecture, master and slave. Here you will have a master which will be called HBase master, and then you will have slaves which will be called region servers, and multiple region servers you will have. If one region server fails, you will still have data on some another region server. And in addition to that, in databases, how you make sure your search is quicker or your response time is quicker? You index it, you keep indexes. So indexes are based on maybe your for example, it uses the B-tree algorithm for your indexes on a RDBMS, right? But in NoSQL space, right, where which are no RDBMS. So HBase is, when you say they are non-relational databases, it means it's a NoSQL database. I will come to in a detail about that. So here indexing and all you can still do, but it's here it is called Bloom filters. The concept is same, but internally the logic is different, but the concept is same. It indexes data for you. So this is how the ecosystem will be. So up till now we have looked at HDFS, we have looked at what are zookeepers, we have looked at MapReduce, we have looked at Flume, Scoop, Hive, Pig, everything we have looked at. HBase is a database which will have a master, which will have a region server. And it also, the file structure will be similar to, the logic will be similar to any other database. For example, it will have a wall. Wall is write ahead log, similar to MySQL. It will have H file, which is your meta file, and it will have your mem store where you can store your data. So I will show you what, I will give you the details of this, what they do. So first of all, what is the main difference between HBase and RDBMS? First of all, in terms of hardware, it is similar to Hadoop. It's a clustered setup, very affordable, because Hadoop does not need any expensive boxes to run. You can put up commodity boxes, obviously not desktop, but commodity boxes, and scale your cluster. But in the case of an RDBMS, let's say you want to set up an Oracle cluster, it will be really expensive in terms of hardware also. Fault tolerance, because it is based on Hadoop, by default it has replica 3, multiple nodes it has, so you don't need to worry about downtime of individual nodes. But in the case of RDBMS, you have to manually configure high availability. Either you have to go for rack, which is Oracle way of configuring high availability for Oracle, RAC, we call it Oracle rack, or any other database, right? For example, in MySQL cluster, you need to set up by using NDB, right? NDB is a MySQL cluster storage engine. So complexities increase. But in the case of Hadoop, the components, how HBase works internally and all, they are transparent to the user. You are just setting up an HBase Hadoop cluster, installing HBase, and it takes care of everything by itself. You can store petabytes of data. Here, there's a limit. You might go to terabytes, but not beyond that. It becomes very complex to manage data after that site. In HBase, It is distributed, and you can have a sparse data set. RDBMS, they are row and column oriented. You can have sparse data set, but it is not encouraged in RDBMS. Your performance will take an hit if you go with a sparse data set. I will show you what sparse data set is. Data types are bytes only. RDBMS supports a lot of data types. RDBMS is fully ACID compliant, right? HBase has an ACID support only on a single row, right? So there are some advantages, disadvantages. So obviously, if you are looking for a transactional databases for storing your financial data, your payroll data, or banks wants to use a database for their transactional purposes for their accounting software, then obviously we will not go for HBase because it is NoSQL, not strongly ACID, and it lags behind on typical Oracle or typical database functionalities. I cannot do multiple complex joins and things like that. So there's a difference also in terms of analysis, data granularity, and the time frame. So in Hadoop and relational, what is the difference? So what this is trying to capture is how much data you can put, the volume of data, and how granular you can go with that. You can do analysis with both, but the scale will vary. Data flows into Hadoop maybe hourly, maybe half hourly, right? But in relational, you have to go for long term trending analysis. So our traditional databases, they are row oriented. Means row data will be in the form of a row, right? So let me explain you what does it mean. Let me pull up my scratchpad. Just give me a second. Okay, in the meanwhile, scratchpad is coming up. So in traditional databases, what used to happen was the data will be in the form of rows. Row 1, row 2, row 3. But here we are talking in terms of columns. Column family. Name, column family. City, column family. Product, column family. So you can say the dimension of the data has changed. You take the same data which you have in MySQL in the format row format. You just turn it by 180-degree and you see the column view. This is row oriented. So this is what sparse data is, right? This is not encouraged in RDBMS, where we are saying ID, username, age, interest. Age is blank, interest is blank. So while we are querying, the performance will take a hit. But in column oriented, I can group it separately. I can say ID and name 1, ID and age 1, null is ignored. Similarly here with ID, interest. So I am grouping it on based off on columns. Again example here. Row oriented will be date, price, size, right? Table of data, and it is converted into row oriented database. Now you have a date row column family. So each is a column family, right? When we go into NoSQL space, I will say there is a date column family, there's a price column family, there's a size column family. So how the architecture is? Again, it is a client server model. We will have a master and we will have slaves. Slaves are known as region servers. Region servers, they run on data nodes. And your master will run in production on a dedicated machine, because master is a very critical component and does a lot of things, so we will give it a dedicated machine. But for your practice, you can put up HBase anywhere and your clients will go on data node. So what it has, so HBase master will talk to its slaves, which will be region servers, which will have your log, HBase log, HBase meta files, and your memory store files. Means whenever you do any operation, it is not directly going to the disk. It is stored into memory and then flushed periodically to the disk. Means committed to the disk. So this is what mem store is. So this is how it will be doing. You put client comes, put some data into a region server. Region server will take that data, put into a region. So what is a region and a region server? Let me show you. Let's say this is one entire table, and in this table one column is date. This date might go into one region server, this might go into one region, separate region, this can go to another separate region, correct? So what might happen on a data node, one region server can have multiple regions. What does it mean? One data node or one region server might have this section of data from multiple tables, right? From table 1 it might have just date, from some table 2 it might just have age. In one region server, multiple regions it can have, and they are spread across multiple nodes for high availability. So HBase can run in three modes. It can run local without the use of HDFS. You don't need to run HDFS, you just untar HBase, run it locally, it will run for you. Second is you can run in a pseudo mode. Pseudo mode means you run your HBase daemons, but everything runs on the same server. Your region servers, your master server, your zookeeper, everything runs on the same server. Then is fully distributed mode, where your two HBase masters for high availability, similar to the name node high availability, we will put on two separate nodes. We will put region servers on separate node, and we will set up zookeeper for high availability. So for example, how the HBase query will be. There are no SQL queries. I cannot say insert this data into this particular table. I will say create instead of insert or create table. Create class column family. Instead of insert, I will say put. Instead of select, I will say scan. Right? So terms change. So how will be the configuration? So let's go to a system and configure HBase. So for that, let me first of all show you that my cluster is up. I'm running one name node. One name node, 4 data nodes, one resource manager, and 4 node managers which will be running on each data node, one client. This is what I'm running. Right? So this is the same machine on which we have configured Flume, Hive, everything. So now today we will set up HBase. So first thing for setting up HBase is, let me just copy HBase. So I'm taking HBase 1.0.1.1. right? So same HBase is again a project under Apache. So I can go here on Google, search for HBase, download. It will take me to HBase site. I will say click here, and I can see it gives me a link from where I can download HBase. Go for a stable release 1.0.1.1. So that's why you see a version which I've already downloaded, this one. So I'm copying this Hadoop at the rate 192.168.1.99. I'm copying it into its home directory. So I'm copying this onto client. Let it copy. So first of all, what we will do is we will set up HBase, and multiple things are here. See, HBase is getting copied. Okay, so once it is complete, let's go back here. I'll clear the screen and let me just show you the HBase. See, HBase is here. So I will say tar -x zvf, and I'm doing an HBase untar of HBase into my present directory, which is Hadoop's home directory on my client. So in production, you will give it a separate dedicated machine, but here for the sake of our lab, I'm using the client as one of the machines where I'm installing HBase. But in production, you will give a separate dedicated machine which is not a client machine, because client is the machine where users will be logging. So again, installing HBase there will not be the right thing, because your users will be again jumping and sitting directly on the HBase. Untarred HBase. So I will create a symlink, give it a name, easy name, HBase vi.bash profile. I will copy it and I will say HBase now, and I will change the last name to HBase, right? And same thing I will put here also. I will copy it and I will paste it. I will say HBase. Correct. So I have added the path and the variable. So I'm just re-exporting it. Now I say which HBase. So I am able to find HBase. So if I do ls-l HBase, the directory structure will be same as we are used to it. Bin config directory. So bin will have your commands, right? And your config directory will have your configurations. cd HBase config directory. I go here. I open this file, environment file. Here you will tell the path where your Java is, right? You will tell the path wherever your Java is. I'll save it. Let me just do a cat on profile and we'll tell it where our Java is. Right, so I'm commenting out the old document. Right, so I'm saying Java is here. Then if you want to configure heap size, I can control it here, saying maximum 1 GB. I can reduce it if I want, right? It's saying maximum. Right, a lot of configuration parameters, but main thing is we need only to set up Java. Okay, vi HBase hyphen site. Okay, so now here what we'll be setting in HBase hyphen site, we will be setting up the Hive configuration or the HBase configuration. So first of all is your standalone mode. So you can refer my GitHub. So in standalone mode, what I'm saying is I'm telling, let me just go to the system. That where is the root directory? I'm saying create a directory called hdata under home Hadoop. There's also a zookeeper directory. Create there. I will save it. Region server, anything I don't need to bother about. I'm saying it's localhost only. Region server, everything is localhost only. So now I say, after doing this, I will simply start HBase. I will simply start HBase. See, the HBase is up now. HBase master is up. So I can do HBase shell right. So it has given me an HBase shell. So I will say HBase a shell to HBase. So here I can now execute the commands like this. For example, create a class, no need to put comma, or you should not put comma. I should not say no need, you should not put comma. I'm putting data into it. I'm saying put this into class. Let me say put row 2. Then I can say scan single quotes class. Right, so it is giving me a column family. So it's not insert, put, insert, select and all. It is get, scan, put, scan, those kind of things, right? So this is my HBase. So once I quit from here, now you will see pwd present working directory. It created a zookeeper directory for me. It created an hdata directory for me, right? So you can see wall transactions it created a data directory for me, right? Similar to MySQL, right? So this is local mode, standalone mode, where I do not need HDFS. Now I will say stop HBase. I'm stopping HBase. Now we will go into fully distributed mode. So in the meanwhile it is stopping. So let me go back to the slides. So we said store your metadata or data locally and create a zookeeper directory. It automatically did things for us and started HBase in a standalone mode without worrying about the cluster. But in production, we will set up in distributed mode, right? So we'll say clusters is distributed is equal to true, and I will tell which all should be my zookeeper quorums, right? So in high availability, if you remember, we did name node high availability using QJM, Quorum Journal Manager, in which we have set up zookeeper in advance before setting up high availability. But with HBase, we do not need to set up zookeeper initially. It is bundled by default with it. The moment I say hbase.cluster.distributed is equal to true, HBase knows that I have to start zookeeper. I will just tell 3 nodes where it should start, and it should have the HBase packages or the zookeeper packages. It will start zookeeper for me. Okay, so now stopped. So now let's go back to the directory. I'm sitting in HBase config directory. Vi HBase hyphen site. I will open this file and I will remove all this. And what will I put here? First thing I will say that it is distributed. Right? First thing I'm saying is it's distributed. And where will be my HBase data? Initially we were saying Hadoop's home directory, HData directory, right? Now I'm saying it should be on Hadoop cluster. This is name node slash HBase directory. Distribution true. I'm saying 3 nodes will have your quorum. So let me show you Hadoop fs hyphen ls. So there will be no directory by the name of HBase which we have given. It will automatically create on Hadoop cluster. cd backslash. Now I will just clean up all this local which you have created. We do not need that. Right? Just to show you that it is nothing is coming now locally. Zookeeper also I'm deleting. I go back. I open HBase hyphen site file and I'm saying on Hadoop cluster create a directory HBase where HBase will store all its data. It's a fully distributed and it will use a quorum on 3 nodes. So what I have to do? Save this. Now VI region servers. Region servers are slave nodes. I will tell where all it should have region servers. dn1.cluster1.com. I'm giving 3 nodes. dn2, dn3. 3 nodes I'm saying will be its region server. Similar to slaves we have given, here we are saying in region servers file all the nodes where it will run the slave of HBase. dn1, dn2, dn3. Currently I have only 4 nodes, so I'm giving 3 out of them. And the fourth one, what I will do, I will create a file backup hyphen masters. Here I will write dn4.cluster1.com. What I've done, I've created one more file backup masters. Inside that I've given dn4.cluster1.com. So what it will do, now it will run 2 HBase masters. One, this node itself. Second, dn4, and it will run 3 slave nodes, which will be region servers. Correct? So let me come back. I will do scp-r HBase. I will copy HBase. This HBase to 192.168.1.72 home directory. So I'm copying the same configuration everywhere, right? So let it copy. It will take some time. So I'm copying that data, whatever configuration we have done on the region server. I'm copying that to all the nodes, means DN1, 2, 3, and 4. And also, obviously, we need to, let me just log into the box machines one at a time, side by side. What you have to do here is vi.bash profile. So obviously we have to modify cat.bash profile. We have to write this on each of the data nodes, and I have to write this also. I'm saving it on DN1. Now let me copy on 73 also. So let me SSH to 73 also. Okay, I'm copying to 72.1. Okay, save one time. Okay, let's copy this and 74. Okay, so let me just copy this file, scp 192.168.1.74 colon home directory here. 74, 75, correct? And we can see HBase is coming here. Okay, and 75 also. So all nodes where it will be running region servers and the backup server. So backup server is running on 75. All D1, DN1, DN2, DN3 will run region servers, and 99, which is client, will run one of the HBase masters as well. So let me go to the browser. 192.168.1.99 colon the HBase port, right? Let me start up the HBase server, then I will show you. Okay, so it is copied. Now let's do start HBase. Now look at the message which comes. So it is connecting, and now it is giving a message saying it is starting Zookeeper and it will be starting the services. So give it a minute, it will come up. Yeah, I'm not sure my voice is that clear because I'm still having bad throat. So please bear with me. So things will be much easier if we could have set up a password, uh, passwordless access between them. Right, see, HBase master is up here. Okay, let me see. I think there's some change we have done it. Oh, Java is not there. Just a second. Okay, just let me just quickly rectify this. Not 73, 74, 75. Right, so here you can see quorum managers are up, region servers are up, everything is up. Right, and let me just go to dn4.cluster1.com. And you can see a second master here. Okay, just a second. I forgot the HBase port. HBase port 600160020 160020. Okay, just give me a second. What we can do is, let me just do a netstat here, -tlpn. Yeah, 16020. me a second. Because they keep on changing ports so often from one version to another version, it's very difficult to remember all from the top of the head. Because initially it was 60010, then they changed to 1600 something. Okay, just give me a second. Okay, yeah. So port is 16010 in HBase 1, higher than HBase 1. If you're logging using HBase any prior to that, it is 60010. Right, 60010. Any HBase after HBase 1, it is 16010. So now you can see it is telling me currently this is the master, which is client1.cluster1.com. So obviously this is the node where we started HBase. Then it is showing it has 3 region servers and it has one backup DN4. So let me just show you. If I stop HBase here, or let's say let me kill the HBase here, or let's first insert data. Right, so let's put some data into HBase. Writing some data, right, and I'm doing scan class, right. I can see the data. You can see memory, table details, the table which we inserted just now, HBase configurations, matrix dump, means I can see what is the performance. It will give me in JSON. Log level, all those I can change. But let's go back home. So currently master is client 1, right? Client 1, and it's giving me some details. These are the zookeepers. Here it is storing my HBase data. Hadoop fs-ls. So it will create, it would have created a directory called HBase. Right, so you can see it has created a directory. So what I will do is I will go to now client. Let me exit out of it. JPS I'll do, and I will manually kill this. Gone, right? So now let's go back here. So now obviously I cannot see on 99, so it has gone to 75, right? But now it is showing me this is the master now. 3 servers, there's no more backup because the other node is down, right? But your query data, everything will be same. I can run this scan because other HBase master is up. You can see table is up, backup master is not there. It has already switched over to DN4. 3 region servers are there. Right? Your data is there. So this is distributed mode with high availability, in which we have set up 2 HBase masters, client and DN4, and 3 region servers, which are slaves. So currently, the table which you have inserted, right, user table, has gone here because it holds 1 region server. Right? It went there. So this is what it is, HBase master. Okay, let's go back to the slides. So this is distributed mode. So we can set up HBase with Hive, right? So on that day, I discussed and showed you that what is the advantage of setting up Hive with an external table. When we create a table, we will put the keyword external so that it is not managed by the Hive, right? So whenever we delete a table, it should not go. It should not delete the data. It should only unlink from the Hive schema. So what we have to do in HBase also, we have to create an external table. I've given the command here. So this was given as an assignment to everyone. If you're not able to create this, just execute this command. Create external table, any table name, correct? And you will, this should be the, first of all, what you will do, you will create a HBase table by this name, have some data there, right? And then you will query it from Hive. I can show you if you want, right? So let me just show you this example. Let me just create a table for you. I'm creating an HBase table. I am putting some data into it. I'm inserting some data. Right? I can do scan this table. Right? But how will I query this from Hive? So what I will do in Hive, I will execute this command in Hive. I'm giving the same table name whatever I have created here. I can either go to Hive prompt or I can pass the Hive-F option, and the file name, it will give me a Hive. Okay. So what is happening here is service MySQL D restart or MariaDB. So database MariaDB was not running. That's why Hive did not run, right? Because if you remember from our last class, we have done a connectivity between MySQL and Hive. The metadata is in MySQL. Scroll the screen up. I say user/Hive slash warehouse. It has something over there, which is test Hive DB. So I go in Hive and I copy this. Right, so it has given me a Hive table, a table which can interact with HBase. Empty currently because it is having only metadata, the schema, but your actual data is in HBase. So I will do select. So in HBase, what we were doing till now, in HBase we were simply saying scan. If I go scroll the screen up, see here I was saying scan Hive table, right? So here I can say select star from sorry, from this table name, right? So this is coming from HBase. So this was your assignment which was given in the last class. How to connect Hive to HBase. So data is not anywhere. See, you can see this directory is empty, but it is going to HBase and pulling the data. Right? This is integration with Hive. So now the another phase, another important part, which is MapReduce. So up till now we only talked about map and reduce. But intermediate also there are a lot of phases like shuffle phase. Means it moves the data across multiple nodes because the same set of keys should occur in the same region. So what does it mean? Let me show you. I will come back to this slide. For example, let's say you're doing a MapReduce word count on this file. First line went here, split, second line, third line, and then it does some mapping. Deer happened one time, beer, river, then car one time, then again came deer, car, beer. So obviously all the keys which are deer should go to one, right? It should not be beer is here and deer is here, right? So this is called shuffle phasing. So it is shuffling the same keys. All deer will go one place, all car will go one place, all beer will go one place. So this process is called shuffling across a common key. So all the common keys will always shuffle and go into one bucket, and that will go into your reducer will sum up and give you an output. So this is called shuffling. So it is happening across multiple nodes. So what is happening, let's say this might be node A, means your data node 1, data node 2, data node 3, and these may be same node or separate node. So your same key might be going to dn4 beer, this might be going to dn3, this might be going to dn2, right? River might be going to dn1. So it is shuffling. So shuffling is an expensive process because it is moving data across. So what we have to take care of, how efficient we can make these shuffling. Right, less number of shufflings to do will be the best thing, but sometimes it is not easy to control how shuffling happens. So what we can do is we can make sure the data which is transferred across these nodes, it is minimal. How it is minimal? I will do the combiner phase here itself. For example, saying car twice and sending it over the network, I will combine car locally here. I will say car comma 2. This is called combiner phase, right? By default it is not enabled, but we can enable combiner phase. It will combine on the reducer side, on the mapper side, right? This is reducer side combine, which is there enabled by default. I can enable combiner on the mapper side also. The data which is going across is uncompressed by default. We can enable compression by saying compression is equal to true. So all the data which goes across the wire will be compressed. A lot of details are there, right? So what is happening? Node 1, node 2, node 3, they might be running map phase. Then shuffle happens according to the keys. Each might be going to separate node. Then reducer runs and finally writes the output. So this is what happens. First split, HDFS input split. Each map is assigned to one HDFS split, which is one HDFS block. It will read it, sort it according to key value pair, sort it, each map is sorted. Then it is shuffling. See, you can see this is shuffling phase. Then it is merging and giving you an output. So shuffle phase happens on the reducer side. So you need to decrease this traffic, red color traffic, as much as possible. So how we can do all those things? First of all, whenever we run MapReduce job, any MapReduce job, it takes some data from HDFS, writes some data to HDFS. But what about the intermediate phases, right? All these intermediate phases where it is doing this, where all this is going, it is going to non-HDFS space, right? Non-HDFS space. So I have to tell by default, if we do not configure anything, you will see all this going into temp directory, right? You can see all these temp directories. But what happens in production, we will set up mapper.local.dir. Similar to dfs.data.dir we were setting, we will set mapper.mapper.dir in mapper-site file or yarn-site depending upon which version of Hadoop you are using. And this what it tells where your intermediate computation should be stored. So here we will give multiple disk drives to have better read write performance and read performance, right? So we will, it is non-HDFS space, so we will give 3-4 disks under this, similar to how we will used to give dfs.data.dir comma separated list. We will compress the mapper output. So this is what I was telling you, the output which is going from mapper to reducer, this is mapper sending to the reducer side, right? We will be compressing that. So what parameter we will set up in mapper-site, we will say mapper.compress.map.output is equal to true, right? It will enable compression for you. vm.swappiness, we don't want swapping to happen. We will set this to 0 at the OS level sysctl. This is I, not L. io.sort.mb. What is this? io.sort.mb is the read buffer, right? So as I said, here if we go back, each mapper is assigned to one HDFS split. So let's say your HDFS block size is 64 MB. So when the mapper is reading that block, it is reading that block into memory. So can it hold the entire block into its own memory? I'm not talking about a system memory. Each mapper also has a memory, and inside that memory which is allocated to each mapper, there are buffers assigned for one specific task, for each specific task. So there's a buffer called io.sort.mb, means input sort and buffer, which is reading this. It's a circular buffer. By default, it is 100 MB. So let's say if I'm going with Hadoop 1, my block size is 64 MB and I'm reading, everything is fine. But let's say I think, okay, 64 MB is not optimal. I should increase the block size to 128 MB in Hadoop 1. But it will decrease your performance. Why? Because now your buffer which you have assigned to read is still at 100 MB, but the block which you are trying to read is 128 MB. So it will result in spilling. It will spill again to disk. So it will have a worse effect rather than having an improvement, because now it is reading from disk, again spilling to disk 28 MB extra, then writing intermediate stages, reading again 28 MB left, and again writing the final output. So think is important thing to highlight is, whenever we increase any parameter, it is important that we modify all the related parameters in the pipeline, right? Not just a particular block parameter, not just a mapper memory parameter, but the related parameters. So we should understand the flow of Hadoop, right from the HDFS file system to the MapReduce, how it plays a role. IO dot sort dot factor. What does it mean? You see on the reducer side, one output is coming from node 1, second is coming from node 2, third is coming from node 3. So similarly, one node might have inputs coming from multiple nodes. So what this specifies, on the reducer side, how many input streams you can merge at a time. This is that factor, number of streams to merge at a time from mapper. So mapper is sending output, how many you can merge at a time. So you can set that value accordingly, how many you want, 10, 15, 20, 100. DFS name node handler count. By default it is 10. Means name node is multi-threaded. There will be multiple threads of name node running. So if I go to name node, if I do JPS, will show me obviously only one process. But does not mean it is a single process. It is a multi-threaded process. 10 threads by default. Good enough for a cluster about 600, 700, even up till 1000 node. But if you're going beyond that, increase it. If you're going to 1500 nodes, 2000 nodes, increase the handler count to 60, right? Maybe 30. Take it slowly, increase it, and see how it impacts. But we should increase the multi-threading capability of your name node. Similarly, this is also parameter for data node. So which is 3 by default. Data node handler count is 3. We have to bump that up also. Another important factor, if we go to data node, in data node we have given 3 disk drives to each data node. So by default, what happens if any of this disk fails, data node is marked bad. The data node will go. Even any one of these disks fail, which is not a good thing, right? Because my disk could be very big. I might be having two terabyte disk each, 6 terabyte being coming from one data node. Just one data node going down, I'm again losing another 4 terabyte. So I can control that by setting up this parameter. How many volumes I can tolerate as failed. By default it is 0. So what does it mean? I may have 3, 10, 20 disk drives in a data node. Even if a single disk drive fails, your data node is marked as bad. So I can avoid that by setting this value to 1, 2 or 3. Let's say out in this case, if I set to 2, so what does it mean? My data node will still work with one disk left in the data node. It will not mark it as bad. So obviously it's a good practice to bump this up to depending on the number of disks you have. Similarly, data node is IO intensive. Name node only plays a role. It will tell where the file is. Then the client directly goes to data node and does a read write. So obviously you should have the transfer threads on your data node. Multiple threads are there on data node. Again, there's single daemon but multi-threaded daemon data node. By default, 4096 threads are enabled for a data node, right? I can increase this depending upon how heavily loaded my data nodes are. Another important parameter which plays a very important role in production is client read shortcut. What this parameter does, by default, whenever you are reading any data node will give that data to the client over TCP connection. Means it will send over TCP, right, using a protocol TCP, or maybe it might use over when I say TCP, it might be an HTTP web call over TCP. But What if the data is local? Let's say my client and my data node are same. I do not need to go over a network. I do not need to go over TCP, do a HTTP, REST API call and all. Why not do a socket call, Unix socket call? Much quicker, much faster. So I can set dfs.client.read shortcut is equal to true in HDFS-site file on all nodes. So what it will do, whenever your client and your data node are on the same node, it does not use TCP IP. It goes through Unix socket. A lot of another things. Yarn in Hadoop 2, we have yarn. So total memory allocated for the yarn will be defined by this parameter. Yarn.node-manager.resource.memory.-mb, and out of which, let's say my total memory is 80 GB available to my MapReduce. Let's say take out your OS and all that, they are separate available to me. 80 GB I am left with. So I will say yarn.nodemanager.resource.mb memory-mb is equal to 80 GB, and in that I will say how many containers I can create. I will say, let's say 2 GB per that. So I can means 40 containers. 80 GB divided by 2 GB, 40 containers I can create per node, and I will say minimum containers in that. So there's a formula. The application manager or the application master, which is created whenever the job is filed, is responsible for rounding off the mapper and the reducer memory to a value divisible by this factor. So let's say minimum allocation per container, you say 2 GB, and in within that container you will be running a mapper and a reducer, right? So it will give a mapper and a reducer value which is round off to this value. It will make its best effort, or it will not allocate it, right? It will not allocate it, right? For what does it mean? If application master is not able to find a memory on a system, let's say your memory might be 1.8 gig available, but this value is specified, minimum allocation per container is specified to be 2 GB. It will not start a mapper or a reducer because minimum it looks for 2 GB, rounding off, right? If it is, let's say 2.6, it will give 2 and zero point 0.6 will be left empty, right? Lot of details goes into this, but from a Hadoop admin perspective, there are some important tests which we need to run. What are those tests? So let's say in our first class, what we did was, first or second class, we quickly set up a Hadoop cluster and started running some MapReduce job, writing some data and all. But in production, this is not the right thing to do. We have to certify that this cluster is ready for production use. What does it mean? That data which I write will not be lost. The MapReduce jobs which I run, they will not corrupt the data. They meet certain standards. So I need to do benchmarking on my Hadoop cluster in terms of HDFS file system. What is the input output throughput, MapReduce functionality, how much load my name node can take, can it create 1000 files in a given unit of time, can it delete 1000 files in a given unit of time. I will stress test name node, I will stress test HDFS file system, I will create some dummy files and run MapReduce job and see how it works. So there are multiple tests which are available. So let me show you these tests one by one and we'll go through them. So let me go to my client here. Let me stop HBase. Okay, I have not set the passphrase success, so that's why it's asking me for password. Anyway, we will quickly enter passwords. Okay, so I have set up, stopped, HBase. Let me see here also. Okay, HBase is gone now. Now I'm sitting on client. So let's say I have set up a Hadoop cluster, new cluster, and I want to do a testing, how my file system is performing, how is my MapReduce doing and all, right? So let's test it out. So how we will test out Hadoop. So let me just first of all show you where all the jar files. Hadoop, etc, Hadoop. This is the directory where we saw all the config files, correct? In Hadoop 2. In under Hadoop, if I do ls, you see that there are no jar files outside. Jar files have moved to another location. Right? Under this, for example jar file is there, correct? So I do not need to remember what class it can run. I can simply do yarn jar, hit enter. It will tell me what all classes it can take. It can do terasend, gen, terasort, teravalidate, all those things. I will show you what all these are, right? So similarly, there's a class, right? Let me scroll the screen up. On this path, there are multiple jar given to us for doing benchmarking. So there's a job client test jar which gives you distributed IO test. I can do distributed test IO, means for the file system. I can do name node benchmarking. I can do MapReduce benchmarking. I can do a load gen marking, right? So let's take things one by one. So let's start with test DFS IO first, very first one, right? So let me go back to the slide. So file system IO throughput. What is the throughput of my HDFS file system? How quickly it can read write, right? So let me start this. I'll give the class name test DFS IO. What test I'm doing? I'm doing a write test. N files. How many? I don't need to remember all this. I can simply enter here by giving the name of the class. So it will tell me what all parameters it can take. Right. So I will give here hyphen write hyphen n files, means how many files I want to write. First is write test I'm doing, and the file size. Number of files, let's say I'm saying 6 files, and hyphen file size I'm saying 1000 MB. S is capital, and here file is capital, right? So now it is saying test 6 files, each file of 1000 MB, means 1 GB. So it will create 6 files, each of 1 GB, and it will give me a statistic saying what time it took to write these files. Let me close this. Let me close this. So it's under benchmarking. In GitHub also, I've given this under benchmarking. right? It's running map phase, reduce phase. So we can do a write test, read test. Similarly, we have name node benchmarking. So in our initial classes, you remember, right? So name node is the one master which has a requirement, high requirement for memory because all the metadata sits there. So having smaller files is discouraged. Why? Because name node, each entry will go to name node, but my I'm running out of space, but namespace is getting used. So doing this test, what I'm doing is I'm explicitly creating small files. I'm saying name node benchmarks operation is create. I'm saying 12 mappers, 6 reducers, very small files, one block size files, bytes to write 0. Do not create any file. I'm just testing name node for its metadata testing. Number of files, I'm saying create 1000 files, replication factor 3, and just do a read also after creating into this directory and tell me how it performs, right? And tell me how it performs. Similarly, MapReduce benchmark. What does it mean? I will run multiple MapReduce jobs, same job multiple times. Let's say it will run a dummy MapReduce job 50 times. I'm testing my cluster to see whether it errors out after something, or does it take that much load, or I'm checking the consistency. MapReduce benchmark, right? So let's take one by one. Test DFS IO. Okay, still it is running. I've given 1 GB files, which is big for my small cluster. And another reason is why it is running slow. This I'm running on my laptop, which is having virtual environment. Means all my machines are in my virtual box, right? And all these virtual box has virtual hard drives from a single physical hard drive of my Mac. So the contention is going to the same physical hard drive. But if I would have run this test on my another desktop which I have, where I have 3 physical hard drives and I have distributed these virtual machines across them, you will see almost twice the difference in the performance, right? So it makes a lot of difference. In production, obviously, we will not be having this kind of a virtual environment on a laptop. I'm just showing you for a demo purpose. Okay, so it gave the output. Total out bytes processed, throughput mega bytes per second, IO mega read, right? Standard deviation. So it is giving you an output. Same I can do for read also. I can test the read write, right? Now ls-l. Same benchmark what I have run here, it will be written to Hadoop cluster under benchmark directory. It will create a benchmark directory and write it there. So any questions till now? Right, so this will do a lot of benchmarking into it. So we will compare these tests. So when the cluster is set up, after doing all these tests, we keep a record of these benchmark so that tomorrow we have to find out if cluster slows down. What was the initial values we had when we set up the cluster and cluster was not having any data on it. This kind of gives us a benchmark. Okay. So now let me show you very small file. Instead of 1000, I'm just running you a test. Let me create 100. MapReduce, let me reduce the MapReduce also. Let me create 6 MapReduce, 3 reducers. Okay. Which test I will be running now? Second one, which is NN bench. I'm just testing name node. It is not writing any files data, but it is just testing name node. By creating 100 files with replication 3, block size just one block size. I'm not writing any data, right? It is quickly creating and it will give me output how quickly a name node can create files, update metadata. So if I go here, if I do df-h slash data slash name node current ls-lh, right? Right. So it is doing that testing. It is doing stress testing for name node. Okay, so let the test run. In the meanwhile, let me show you a few other tests. So after this name node, I will show you one MapReduce benchmark. So this will be running MapReduce job repeatedly 50 times, right? I can show you 2 times or 3 times. It will generate data for you. And after that, one I will show you what TerraGen. It is very important. So what happens is in a production cluster, let's say even this home cluster, I will not have 1 terabyte of data with me to play around, or even forget about 1 terabyte. Finding about, let's say, 100 GB of data to test on my cluster is a challenge unless I have some data store. So how will I test whether my cluster can handle data or not? So Hadoop by default gives you a class called TerraGen, which generates terabyte, which can generate multiple terabytes of data, large amount of data for your Hadoop cluster, dummy data, and you can test your capacity, your performance, how quickly it can generate that much data. And what it does is when it generates the data, you can say generate data into this directory. You can sort that data and then validate that data, right? It will give you an output file if validation fails. So in this way, what you are doing is you are testing your cluster for MapReduce and any file corruptions or the file system level and functionality as well of your cluster, making sure your cluster can work at large scale. You can generate 10 terabyte. Obviously, you should have space. My cluster does not have space. It has only about 48 gigabytes. But I will show you on a very small set, maybe on 2 gig or 3 gig. So when I say 1000 here, right, it means 100 byte records, 1000 100 byte records. TeraGen. It will create 1100 byte records into this, then sorts it, validates it. 3 classes. Okay. So now you can see benchmarking has been done. Date, timestamp, MapReduce number of files, create, close, all this. It has number of files, right? Checksums. It is able to do that. All these metrics. Now, now let me show you TerraGen. So what I'm telling it, I'm saying Terragen class create 1000 records each of 100 bytes. By default, this is the number of record 1000. By default, record size is 100 bytes. So each record of 100 byte create 1000 into this directory. I can give as many zeros I want depending on the size I have available in my Hadoop cluster. So it will run it, create an output directory with some dummy data. I will sort that data, say Terra sort input directory, and I say out1 is the output directory. It will Terra sort that data, and in the end it will validate that data. Here I am running on a very small set. I have given the number just 1000, but here you will be giving a very big number in your production depending upon how much disk space you have available. Right, so see, it sorted out. Now I will do Terra validate. I'm validating it. Final, let's say final. What I'm doing, first I did Terragen, generated some data, then I did a sorting, and I'm doing a validate. I'm saying write into final after validation. It will write me a file if it finds any error. It will write me an output file with the detail whether job succeeded or not. It will write the checksum if everything is fine. My Hadoop cluster is fine, no corruption, MapReduce is working fine, infrastructure is fine, and I'm good to go. I will say now I've tested the cluster, it is production ready. So here benchmarks we are running very small, they're taking 2-3 minutes, but in real case in production we will run huge benchmarks so that your cluster keeps on running maybe for 2 days. It's running a MapReduce job for 2 days to test out its functionality. So Hadoop fs-ls final, right, it's writing a success file, and part file if I get, right, so success means it is successful. Right, so it's a dummy data, so checksum it will generate for you, right. This checksum will not be generated if Hadoop did not perform well. Even in terms of Hadoop FS file system, some block corruption happened, some HDFS issues or MapReduce issues, right? So MapReduce not working correctly the framework, so it will not write to you the checksums. Results will be seen here also. Benchmark, name node benchmark also will be seen here, right? So this is how you will be testing out your Hadoop cluster before you say it is fine for production. So this I have one slide I have taken. So this has a lot of details, right? So this is what I was explaining you. Let's say your system has 8 GB of memory, and you say that each node maximum can take 8 GB of memory. This is the maximum allocation. Minimum allocation you're saying 1 GB. So means you can create 8 containers, right? The node manager, you're saying this much memory, right? And then you will say heap size and all you will control from this, right? So refer to this slide, which will give you an idea that if your total memory is this much, how you will divide the memory into the subparts, right? So the formula we use for calculating the vmem and the pmem ratios is 1.5 into the memory which you have available, whether it's 3072 or or 2048 into 2.1. Okay, now let's go to another interesting thing is snapshot. So what is snapshot? So let's say I have some data on Hadoop cluster. Mm, okay, let's say input directory. Let's create some input directory, mkdir. I'm creating some directory. Let me see what files I have. Vi first dot pig. Okay, let me say vi test dot txt. Let's create some file. This is test file. I'm copying this file into input directory. Right, so let's say this input directory which I have, it's critical directory. It has some important data. I need to back up this data so that somebody by mistake should not delete it, or if they delete it, I should be able to go back in time and recover the file. So what I have to do is I have to enable snapshotting for it. So what is snapshotting? Snapshot are read-only point in time copies of your system. For example, it will take a snap of your system at that moment and keep it. So it does not occupy any space. It's just a symlink to your file. It does not occupy any extra space. So what I will do is I will do HDFS, hit enter. No need to remember the commands. So I will say HDFS DFS admin allow snapshots on input directory. So you have to enable the snapshotting for a directory. By default, it does not mean that any directory you create will be you can take snapshot of it, or it comes under the mode of recovery. So you first of all, what you do, you enable snapshotting by saying allow snapshot, allowed snapshot. So now I can see, if I want, what all directories have been enabled for snapshotting, or I can disallow it. I can do list here what all directories which are snapshot enabled. I can disable a snapshot. I can look at a difference from two snapshots. I can rename a snapshot. I can delete a snapshot. I can schedule a snapshotting automatically. Means at this time snapshot happens. Every day at 5 p.m. snapshot happens, right? But let me give you an example. I've enabled snapshot for my directory input. Let's create a snapshot for this directory input. I'm creating a snapshot and I'm giving a snapshot name. Snapshot name it, let's say today's date, Saturday 15th August, time is 8 8:50 8:50 p.m. It created a snapshot. So if I do Hadoop fs-ls input, you will not see that snapshot because it is hidden. Dot snapshot, it is hidden. If I do dot snapshot, snapshot, it will be there, right? I can go here into that time slot and I can look at what all files were there. So for example, let's say Hadoop fs-ls input, by mistake you delete this directory, delete this file. File is gone. By mistake somebody deleted it. So what I can do is I can recover this file from snapshot. I can give this path, snapshot path, I can recover it. Let me show you the contents as well. Right, it is recovered. So now somebody might ask, what if I delete the directory itself? What if I delete the input directory which has a folder called .snapshot? Okay, let me show you that also. It will not let me delete it. Cannot delete any directory which is snapshotted. You cannot delete it unless you disable a snapshot on it. So you have to go back, disable the snapshot. Then only you can delete it. So obviously these all commands can be executed by root only. DFS admin, HDFS admin only by the Hadoop admins. Then only you can go back and delete the directory. Right? So now it is not letting you delete again. Why? Because it still has a .snapshot directory. So I said here where disallow snapshot. Please redo after removing all snapshots. So it did not allow me to disable the snapshots initially. So what I have to do? I have to remove all the snapshots. Snapshot. Let me see the name of the snapshot. Right? So this is doing a safeguarding. This is doing a safeguarding. So first of all, I have to go and delete it. So I was showing you I cannot simply do rm, which is a command I can be executed by user. So I have to first of all take the help of an admin, ask him to please disable a snapshot for me. Delete snapshot for input directory called this one. Go on now. Now I can disallow. Right now I can do rm-rf on input. Gone. Right, so this is how snapshotting works. demo we have seen. The last part is NFS, right? So let me quickly show you NFS as well. So what is the advantage of NFS? As we all know from all those who are from networking background, what it let us do is, on up till now what we have to do is, let's say if I'm sitting on this client machine, I have to copy some file to HDFS. I have to use the Hadoop command, Hadoop fs hyphen put some file name onto Hadoop cluster, or copy whatever. But why not mount HDFS into some location, let's say on some another Unix box where you might not have HDFS client installed, you might not have Hadoop commands. So how will you do that? Can I mount it as an HDFS or not? Correct. So this is the point here. cd Hadoop etc Hadoop vi HDFS hyphen site. I will go here. I'll write this here. What it is doing? It is telling me dfs dot nfs3 dump dir. Why we are giving this parameter is because whenever you are writing changes to NFS, right, whenever NFS will be mounted on client machines, your writes might come out of order. So what this directory does, it will go into this directory temporarily, and then they will be ordered and written into it, right? So that file blocks do not fall out of place. This is how similar to export fs is, who all and which all can mount, and as what. I'm saying all hosts are allowed into read write. Saving it, I go to name node, etc Hadoop vi HDFS hyphen site, saving it, cd Hadoop etc Hadoop vi HDFS hyphen site, going here, saving it, and I can copy this file to all other machines. 192.168.1.72 colon / Hadoop etc Hadoop. /72 73 74, right? And on name node vi core hyphen site, and I'm making an entry of which user those NFS files should be written as, right? So I'm setting a proxy client kind of thing here. So I'm saying proxy user any who can proxy as Hadoop user. And host star. I say stop dfs.sh, start dfs.sh. So let it start.